For more videos like this for Discrete 1, you can take a look at Sarai Studies, link is in the description box below.
All of the propositions that we have seen so far have been atomic propositions. So think of atomic, atom, as small. So these propositions have been as small as they can be. An atomic proposition is one that can't be broken down into other propositions, or in other words, smaller propositions. For example, I studied is an atomic proposition because it can't be broken down into other propositions. We can call this proposition P, and proposition P is as small as it can be. It's an atomic proposition. Unlike a compound proposition, which is one that can be broken down into other propositions. For example, I studied and I passed my exam can be considered one proposition P, but it's a compound proposition because you could take a look at it and break it down into other propositions, into smaller propositions. We can call this proposition R, we can call this proposition Q. The variables do not matter. So these themselves are atomic propositions, but when put together, it's a compound proposition. So notice, compound propositions are combined or connected with what we call logic operators or connectives like and, so in this case we see an and or and more. So how can we translate this proposition into discrete language? Well, we can call this proposition, let's just say P, we can call this proposition Q. So we have proposition P and Q. But how do we represent and in discrete? Well, there's a symbol for and it's this, and the way that I remember it is that this symbol looks like an A, so A for and then the opposite of that symbol is or. So if I have or here instead connecting these two atomic propositions, then it's going to translate to being P or Q. Another logic operator is the not operator. So you can write it like this or like this. Garcia uses this symbol, so that's what I also use. And it's just a fancy way of saying opposite. So if you have a proposition P and you put a not in front of it, you're just saying take the opposite of P, and the opposite of I studied is I did not study. So not P itself is also a compound proposition, and an easy way to remember it is anytime you see any type of operator, it's a compound proposition. The only time it's an atomic proposition is if you just see the proposition by itself. It's as small as it can get, or it's as atomic as it can get. So in the next video, I'll show you how to construct truth tables for these compound propositions, and I'll also introduce you to some other operators.